Okay, as you guys are rolling in, I just need to know if you have any questions from the last section. So from 4.1, do you guys have any questions from the homework from 4.1? Questions.
I was struggling on number 19.
Oh, wait, hold on, Janie. I can't hear you. I think it's on your side. You might need to talk up. Oh, you're on mute. That's fine.
Can you hear me now?
Okay, now try to say something.
Can you hear me?
No, I can't. Hold on. No, I can't hear you. It's weird. Are you typing something?
I was trying to fix it. Can you hear me now?
Yes, I can hear you now. Now you're coming in loud and clear.
I had a question on like number 19. I just for some reason couldn't get the right answer on it.
Yeah, let's look at it. No problem. So like if we go to 4.1, so section 4.1, number 19, which is on page 285, it says 4x minus y equals 9 and 2x plus 3y equals negative 27. Now, this question asks us to solve it by substitution method. Janie, what did you do first? What was the first thing you did when you tackled this one?
I did it like 3 different times.
Oh, like talk towards the laptop because it's hard to hear you.
My notes real quick. I took the the 4x minus y equals 9, and I moved the 4x, I subtracted it from both sides and then moved it over to try to isolate the y.
Perfect. So let's go for y here, which is in equation 1, right? So move the 4x over, and I wind up with negative y equals negative 4x plus 9, right? Then I've got to get that negative to go away, so I'm going to divide the negative 1 by everything. And I wound up with y equals 4x minus 9. Okay, are we good there? Okay, good. So now I'm gonna box this in because I've isolated y, and then I'm gonna put it in to the other y, right? So I'm gonna pop that over here. So I get 2, this is equation 2 now. 2x plus 3 times 4x minus 9 equals negative 27. So distribute the 3, and I get 2x plus 12x minus 27x, or 27 minus 27, right? Add the 27 over, we get 0, which is fine. We can have 0 on one side. So we get 14x when we add these two together equals 0. Well, that kind of tells me x has to be 0, right? Because anything times 0 is 0. 0 divided by anything, 0. And we wind up with x equals 0 is our x coordinate or x component of the solution. And then I'm going to take that and I'm going to plug it back into the box. And I wind up with y equals 4 times 0 minus 9. So y equals negative 9. Do you see what you were doing?
Yeah, I think I was just, whenever it got to the 0, I wasn't doing something right. I think with like my multiplication or division or something.
Oh, okay. Gotcha. But yeah, what'd you say?
I said thank you.
Yeah, no problem. So the solution is 0, negative 9. That's a great example from that section. So this is from 4.1 still, guys. But it's number 19 on page 285. Any other examples before we get rocking and rolling today? Or any other questions from previous homework?
I have one on number 41.
Same section?
Yes.
Okay.
The
Who am I talking
fractions.
to?
Amanda.
Amanda, okay. Yeah, it doesn't pop up for some reason on my thing saying that you're talking. It's weird. You said 40.
41.
Oh, Lord. Yeah, let's go for a trick on how to get rid of fractions. How about that?
Yes.
Okay. I'm going to look, this is 41, and I'm going to just look at the first equation first. 1/3 x plus y equals 4/3. Okay. There's a really cool trick, and I can use another color too, which is nice. It says, look, if we've got an equation, it's got to be an equation. It can't be an expression. We got an equation, especially if we have common denominators in the equation. All you have to do is multiply every single term by a common denominator. Okay. Now for this one, the common denominator is pretty easy because it's 3, because it's the only denominator in both of these. So you've got to multiply every single term by 3. Okay. When you do this, 3 times 1/3 is just 1. And really what happens, these 3's cancel. You wind up with x. Plus 3 times y, that's 3y. And again, these 3's cancel. So it equals 4. So in one step, you've gotten rid of the fractions, which is, I mean, it'll make your life a lot easier, especially this section. So we look at the other one, we've got negative 1/4 x minus 1/2 y equals negative 1/4. Well, because the denominators are 4, 2, and 4, we know 4 divides into all of them evenly, right? So I'm going to multiply 4 by everything. It's kind of goofy here, but that's what we're going to do. 4 times 1/4, well, 1/4 of 4 is just 1. Now it's negative, so it winds up being negative x. 4 times negative 1/2, that's negative 2y. And 4 times negative 1/4 again is just negative 1. You see that, Amanda?
Yes.
Super. I'm telling you, it'll help out a lot. Because your book, Martin Gay, who wrote this book, she loves doing that. Where it's like, okay, they get this. Let's throw in fractions and make it a fraction question, and not really a system of equation question. Okay, I'm gonna keep going on this one though. Look, these are our 2 equations now, 1 and 2. This x is already really by itself, so I'm going to move the 3y over, and I get negative 3y plus 4, and then I'm going to plug it into that box. Now be careful, there's a minus sign there. So we get negative 3y plus 4 minus 2y equals negative 1. Distribute the negative. So I get a positive 3y minus 4 minus 2y equals negative 1. It's going to take a little bit. I'm going to add the 4 over and then combine like terms. So combine these together. Oh, hey, 3y minus 2y is just y. Add the 4 over, I get a 3. So my y value I get is 3, which I'm cheating right now and looking at the book, and that's correct. And then I'm going to plug this into my box, right? So I get x equals negative 3 times 3 plus 4. So negative 9 plus 4, I wind up with x equals negative 5. That's my solution, negative 5, 3. That's a good question. I mean, that's a good, I'm glad you brought that up because it is just kind of a quick, it's a quick trick to get rid of the fractions. And then it winds up being a really good example from this section. This was I didn't write that on my own, but this is number 41 in the homework from 4.1. Good question so far this morning. Any other questions before we get rock and rolling on today's lecture? Okay, so let's look at, today we're going to go over 1.1 and 1.6. I'm sorry, 1.6 and 1.7. If you look at the schedule, I'll tell you, these sections should be in a single chapter. And in the newest version of this book, like this, we're working on the 5th edition. The newest version's the 6th edition. She finally puts these 2 sections in one. And it should have been done a long time ago. So if I get both done, we can spend tomorrow just reviewing for the test, which is great. But I'm not going to rush. I mean, well, even if I only get like 75% of these 2 done, it won't take long to finish it tomorrow, and then we can have the rest of the day to lecture if we want to. Okay, So we're going to start. This is on page 49. I'm just going to kind of follow along in the book. But it's section 1.6. And section 1.6 and 1.7 are just on exponents. So we're going to just get, this should be familiar. It's one of those that should be familiar. Some of us kind of struggle with it, so that's why I go over it like you've never seen it before. And hopefully it makes sense a little more sense after this lecture. The main thing about exponents is there's just rules involved with them. And the rules come from shortcuts. So what happened, and I'll give you a basic example, even the idea of exponents came from shortcuts. Instead of someone saying, hey, I don't want to multiply x times x times x times x times x. Let's say we got some equation and it had that going on. I don't want to write that all out. That takes up a lot of paper. Paper is expensive because it's a long time ago. Let's write this in a more efficient way. And they said, well, since it's all multiplied and it's all the same thing, let's just use not the subscript, but the whatever the upper script is. Okay, 1, 2, 3, 4, 5, 6. We've got 6 of these, so therefore it's just x to the 6. Okay, and then because of this, other rules started happening, and they really all come back to just making it more efficient on paper. That's just the best way to kind of think of it. So if we look at something where we had like a number, let's say we had 3 squared times 3 cubed. Well, you could easily write this out and say it's 3 times 3, right? Times 3 times 3 times 3. And there's nothing wrong in doing that. And you'll realize it's, well, there's 5 of them. It's 3 to the 5th, right? But then someone came along and said, hey, notice this pattern here. It says, look, if we've got the same bases and we've got these exponents, if we're multiplying the bases, really multiplying the exponential terms, we can just add the exponents together. And they noticed this. It's just happened over time. So instead of having to write all this out every time, they said, let's just quickly do this rule. And it became a rule. It's called the product rule. Okay? The product rule says, look, if you've got any base and you're raising it to some power, oh, that needs to be a multiplying, not addition, and you're multiplying it to the same base. Now, that's a big rule. It's got to be the same base. All you have to do is combine them by adding the exponents, okay? All you have to do is to combine them is by adding the exponents. Okay, so then let's look at kind of a basic example of this, and we'll throw in some numbers here. Let's say I've got negative 3 x to the 5th y squared times 2 x to the 8th, okay? And look, this is an expression. It is not an equation. 1.6 to 1.7 is really all about simplifying. It's not about solving for an x or a y. That's not what we're going to be doing. Really what we're going to be doing is simplifying this expression with these rules. Okay, we're going to go over quite a few rules, but it's not that you have to memorize the name of the rule or anything like that. It's just after you do the homework, you'll see how it kind of naturally flows. I'll tell you, you know you're done simplifying when you have no repeating bases. So that's what we have here. Oh, let's do up here. We had repeating bases here, right? We got a 3 and a 3. It repeats itself. And because we're multiplying, we can combine them. So I know I'm done there. I don't have a repeating base now. So no repeating bases and no negative exponents. We'll get to negative exponents in a few rules back or forward. Actually, it's on the next page. No, it's on the next section. So we'll get there in a minute though. So let's go back to this example though. So look, if we have coefficients, negative 3 and 2, and we're multiplying, you just have to multiply those coefficients together. So negative 6, not a big deal. And look, the x's repeat here. We've got x to the 5th and we've got x to the 8th. So we wind up with x to the 13th, right? The y doesn't repeat. It doesn't have another y to multiply by. So it just stays put. So we wind up with y squared. Now notice in this simplified version, we have no repeating bases. We've got really a base of 6, or negative 6, I should say. We've got a base of x and a base of y. There's no repeating bases. we're done. And we don't have negative exponents. We're not going to worry about that for now anyway. Okay? Question. Let's do one that maybe looks a little weirder. I'll tell you, the weirder ones tend to be whenever we have number bases. And I know the question always comes up like, well, do we want me to leave it as a number base? For this session, won't matter. You need to know both. If it's a number base and it's multiple choice, you look for the one that's a number base or multiplied out. For instance, if we had, let's say, 2 times x to the 5th times 2 to the 4th times x, let's just say times x, okay? Now look, we've got repeating bases here. We've got a 2 and a 2 here, right? Now remember, if that number is by itself, it has an exponent of 1. So we might want to get in the habit of writing that. So look, I got an x and a 2 that are by themselves, so they really have exponents of 1. Now I can combine these 2's together by adding the exponents. So I wind up with 2 to the 5th power, right? Because 1 plus 4 times x to the 5 plus 1, so x to the 6th power. And you'll see, sometimes the answer is documented this way. And sometimes they say, you know what, 2 to the 5th is not a big number, right? If it was like 2 to the 50th, that's different. 2 to the 5th is not that big. It's just 32. So I'm going to say 32x to the 6th. Okay? But either one of these would be fine. And you'll see that answer written both ways. And my general rule is if I start with exponents, I'm going to end with exponents, but that's just a me thing. I've noticed that's not consistent throughout these books. Okay? Questions about that? We're going to kind of just build on this. I mean, it's really, really straightforward. So next we've got, and I kind of do this out of order, but next we have the quotient rule. It says, hey, you know, let me just show you where this quotient rule comes from. Let's go back to those x's. We've got x times x times x times x times x, and we divide it by, let's say, x times x. Why not? Okay. Now, there's nothing wrong in writing this out. It's just a lot of bases. But we know with fractions, if we have common factors, we can cancel them, right? For instance, I'll do a side note over here. If we had 2 times 3 over 2 times 4, these would cancel, and it would leave me with 3/4, right? That's probably called something like common factor elimination or something. I don't know what it's called. It doesn't matter. But over here, we can do the same thing. Now, we have all the same variable. That's not a big deal. But I know that this x could cancel with this x. And this x could cancel with this x, right? So I wind up with 3 x's. So this winds up with x cubed, okay? Now, if we want to write these, though, in exponential terms, this numerator would have started out being x to the 5th, right? 1, 2, 3, 4, 5. This denominator is x squared, okay? And what you're doing is you're actually eliminating 2 of those exponents up top, right? Remember, this is the number of exponents, the 5. And this is the number of exponents on the bottom. And we can eliminate 2 of them. So this winds up being 5 minus 2. So you subtract the exponents if you're dividing common bases, okay? If you're dividing common bases, we've got an x and an x here, we're just going to subtract the exponents. So let's look at one. I mean, this is a good example, but let's look at another one. Let's say we had 4x to the 9th over x to the 8th. 4x to the 9th over x to the 8th. Well, hey, that 4's got nothing to do. Like, there's not a coefficient in the denominator for it to cancel out with. There's not another number that's a base. So I'm only going to deal with these x's. 9 and 8, well, 9 minus 8 is just 1. You can write it as 4x to the 1 if you want. I'm not going to count off for it. But if it's multiple choice, they're not going to put that 1 there. Okay, just 4x. Questions? Okay, yeah, I mean, it's pretty basic. let's throw a little bit of a curveball in there. Let's say we've got a -5 x to the 8th y squared over, let's say, 20 x to the 7th y squared. This really is going to introduce the next rule, but I like introducing it this way. Okay, so first off, let's look at the numbers. -5 and 20, they simplify, right? That's just a fraction. -5 over 20, they're both divisible by 5. So that leaves me with a 4 in the denominator, but now that negative's got to stay. Now you can put the negative out front if you want. I'm going to just leave mine on top. It doesn't matter. Okay, and you can write it as -1 if you want. There's nothing wrong with that either. But -520 is simplifies to -1/4. Now let's look at the x's. We got 8 x's on top, 7 on bottom. That's going to leave me with 1 x on top, right? Y's are a little different though. What's 2 minus 2? 0, right? Now this is the next rule on this page. Actually, it's the rule before the quotient rule. And it says, look, anything raised to the 0 is just 1. And we've kind of shown why that's true here. Look, y squared over y squared, these are the exact same number, right? That's like saying 2 to the 1 over 2 to the 1. It just completely cancels. These go away, okay? And if they go away, that means you're really multiplying by 1. So we get -1/4. Now you can write the x out front, or you can write the x on top. These are the same. I want us to get used to kind of some different ways these look. Those two are the exact same thing. Okay, and I'm going to go over that zero exponent just a little more in depth. Not with an example, but just a little more in depth. Okay, questions? Okay. So let's talk about the zero exponent. And the rule states something like this. Look, anything raised to the 0 power is just 1. Okay, anything raised to the 0 power is just 1. It's very straightforward, and it does come from the fact when you subtract these, like if I had, x cubed over x cubed, well, anything divided by itself is 1. We know that already, right? I mean, if you divide anything by itself, 5 divided by 5 is just 1. Well, but 3 minus 3 would be 0, so this would also be x to the 0, okay? So it all goes together. That's really where it comes from. It comes from the quotient rule, okay? But let's look at this, and we're going to play around with exponents a little bit because you're going to see a question on the test that looks something like this where you just have to be careful with exponents. Look, the main thing is you've got to be careful with parentheses. If I have like 5 to the 0, let's say -5 to the 0, okay? -5 to the 0 power. Remember order of operations, right? Some of you probably memorized some jingle like, please excuse my dear Aunt Sally or something like that, okay? The very first thing is parentheses or grouping. We don't have that. But the next part of order of operations is exponents. So even though this -5 to the 0, it looks like this whole thing would be equal to 1. The very first thing you've got to do is actually raise the 5 to the 0 power. Because what we actually have here, and this is just a math notation thing, we have -1 times 5 to the 0, right? That's what this means. So order of operations tells me, hey, I've got to raise that 5 to the 0 first before I do the multiplication, okay? So this would turn into -1 times 1 because 5 to the 0 is just 1, and -1 times 1 is just -1. So this would actually simplify down into -1. I know, thrilling. Now, if I wanted this to be +1, I would just have to make one little change, okay? I'd have to put parentheses around the 5, the -5, I should say. That doesn't look brown at all, does it, on here? It's definitely a brown marker. Huh. So now this, look, we're going to do exponents first here because this whole thing is raised to the exponent of 0, okay? Because the entire parentheses is raised to the exponent of 0, everything in here turns to 1. So that is just 1, okay? I know that's goofy. That's why I'm going over it. Okay, that is exactly why I'm going over it. So let's do another one that looks weird. Let's say I had 2x to the 0 minus 2x to the 0. Okay, I think you'll see this one in the homework, or one just like it. Okay, we're going to use what we kind of talked about up here. This first term, the x is the only thing raised to the 0 power, right? So remember, this is really a multiplication. So this becomes, in this first term, becomes 2 times 1, okay? The second term, though, everything's raised to the 0 power. So it becomes minus 1. Now the minus isn't because it's outside the parentheses, right? So we wind up with 2 minus 1. That's just 1, okay? Our solution just becomes 1. Any questions, comments, concerns? It's about to get a little weirder. Okay. So the next rule your book brings up is the negative exponent rule. So let's talk about when this happens. Let's go back to a quotient rule. We didn't really do that many quotient rules. Yeah, we did enough. Okay. Let's go back to the quotient rule, but let's change things up a little bit. What if I gave you, let's use a different letter. Let's say y. Y squared over y to the 5th, okay? And I'm going to write this a few different ways. First off, I'm going to go old school, and I'm going to just write this thing out. Y times y over y times y times y times y. Why did I write so many y's, okay? And just like before, I'm going to cancel stuff out, okay? I'm going to take my red ink, and I'm going to cancel the first y and the second y. Now, what's different about this one is although all the y's go away in the numerator, if everything goes away in the numerator, you have to leave a factor of 1. Because no matter what, everything has a factor of 1, right? I mean, you could write times 1 up here and it doesn't change anything. That's why. So it leaves us with 1 up top, but then on the bottom, we're left with y cubed, okay? That's the old way of doing this. And there's nothing wrong in doing that. But now we know the quotient rule says you have to subtract these, right? But look, 2 minus 5 would give me a negative number. So we wind up with y to the negative 3, okay? Y to the negative 3. And this is what I was talking about. Now I'm going to pause right here for a second and rant. We are not simplified completely with exponents if we have a negative exponent, okay? We can't have repeating bases. We talked about that really earlier. And we also can't have negative exponents. So we have to simplify. We have to make them positive, okay? And the way you make a negative exponent positive is you either move it to the denominator or the numerator. Now this number is technically in the numerator, okay? You could write it like this. So to make that exponent positive, we're going to move it to the denominator. 1 over y cubed. Okay? And notice both of these are the same. It's just 2 different ways to solve it out. Because we're going to wind up with like y to the 12th or y to the 30th. And you don't want to write it out that many times. So you can just use negative exponents. That's what happened. Somebody way back in forever, a long time ago said, hey, look at all these neat rules to make it quicker. Okay? Check out that pattern. Okay, so if we have negative exponents, so now we're gonna look at just negative exponents and simplifying them. Okay, so if I had, let's say, 3y to the negative 2, and the question is going to say simplify or simplify completely. We can't leave that negative 2 in the exponent. Now look, that negative 2 is not being raised to the 3. Okay. Negative 2 is not being raised to the 3. It's only being raised to the y. Remember, there's a multiplication here. So to make this exponent positive, we're going to put it in the denominator. Look, we have no repeating bases, and we have no negative exponents. Okay? So now let's look at one that's in the denominator. Let's say we had 2x over, let's see y to the negative 4. 2x over y to the negative 4. Now notice, the 2 and the x are fine. They're up here, hanging out, having a good time. They're not negative, right? Both of their exponents are really 1 if you wanted to write that to kind of keep track of it. But I've got this negative in the denominator. Now look, so if we have a negative in the denominator, to make it positive, you have to move it up to the numerator, okay? And that's exactly what I'm going to do. So I'm going to say 2x y to the positive 4. Okay? Question, and that's really how we deal with negatives. Now look, I'm going to give an example that I like putting on the test because it's a little different. What if we had negative numbers, like number bases? So what if I had 5 to the negative 2, okay? 5 to the negative. I want you to try this one without me telling you what it is. This winds up being 1 over 5 squared, okay? Because we have to make the exponent positive. And we know 5 squared is just 25. So 1 over 25, okay? 1 over 25. That one pops up. I know it pops up in the homework. It probably is going to pop up on the test too, okay? So just keep that in mind. Okay, so now let's deal with simplifying some of these, kind of put some stuff together. So let's say I had 2x to the negative 7 y squared over 10 y, okay? This one kind of puts about 3 concepts together. First off, I like dealing with the fraction first to just get it out of the way. When I say fraction, I mean the 2 and the 10, the numbers, okay? 2 and 10, when you simplify those, they become 1/5, right? And then I'm going to see what stays and what goes, what moves and what stays, I should say. Well, x to the negative 7, there's not another x to deal with. So I'm going to bring it down to the bottom to make the exponent positive. So I wind up with x to the positive 7, right? And then I've got y squared up top and y to the 1 on bottom. Well, 2 minus 1 is just 1. So it leaves me with 1y up top. Now, I'm going to get rid of the 1 because we have a term up there now. We have another factor. So it winds up being y over 5x to the 7th. Okay? Y over 5x to the 7th. Any questions? I'm going to just keep making these look weirder. Okay, that's the best way to do it. But I need you to know that you can simplify these in a lot of different ways. And the way your brain operates on simplifying these things will probably be different than my brain, okay? And that's fine. So when I do this next example, I'm going to ask you to attempt it. It might not look how you worked it, but we might get the same answer, and there's nothing wrong with that. I actually enjoy that, okay? I'd rather you use your own brain to come to these solutions than my brain, okay? My brain's being used enough right now. So let's look at another one, and I'm gonna kick it up a little bit, and I want you to try it. You try it on your own here. So let's say we had 3x to the 2nd, y to the negative 2 over, let's say 9, x to the 5th, y to the negative 6. So I want you to try this one. I'm going to pause it. This one will take a little bit. It'll take a little bit. So if you're watching this video, I forgot to hit record when I worked this out. But you can see how I worked it out here. And you guys in the class, are there any questions? This is a good spot to kind of stop and see if something isn't making sense, because we've really kind of combined all the rules from 1.6 at this point, okay? You guys have any questions? I'm going to go on to another example like this. I want you to try it as well. I'll try to bring the video back in without it forgetting to unpause it. Okay, so I'm going to go in the homework now and just kind of steal some harder ones in the Let's say, I'm going to do the hardest one. Let's do 82. I say hardest one. It's just the last one. 30x to the negative 7, y, z to the negative 14 over 3x, y, z. Okay, so I want you, that's a negative 14 up there. I want you to try this one now, however you want to try it. I'm going to hit pause and hopefully I'll remember to hit record again. I'm going to just start working on it a little bit. Let me get my pen over there. So 30 divided by 3. We know this. And look, hey, 30 divided by 3 is just 10, right? I'm going to start a fraction line, and I know that the 10 is going to be up top, right? Now I've got a negative 7 and an x. I don't like dealing with that. So what I'm going to do is just leave that x down there, and it's going to become x to the positive 7 on the bottom, okay? Hey, these y's cancel, right? Yeah. There's just a y on top and a y on bottom. Those go away. Now, if you want to say that's y to the 0, that's fine. And then it goes away, right? Because that's just a 1. And the z, okay, I had a z in the bottom. Well, the z to the negative 14, I'm going to put it down as a positive z to the 14, okay? This is how my brain thinks. And I'm like 70% sure that you probably work this a complete different way, and there's nothing wrong with it as long as we get the right answer. So 10 over, now look, I'm multiplying the same base. Those x's become x to the 8th down there, right? In the bottom, z and z to the 14th, that's z to the 15th. Now notice with this solution, or I should say with this simplification, we have no repeating bases. We've got a 10, an x, and a z, right? There's not like an x to the 5th on the top, right? So no repeating bases. And we have no negative exponents. We got an exponent of 1, an exponent of 8, and an exponent of 15. We are done, okay? Any questions about that? Great. Okay, so for homework, I want you to do, I know this is going to sound like a lot, but these don't take long because a lot of them are just 1-step, 2-step kind of things. Now, you're going to hit some that might take you longer because it doesn't quite make sense, but it's going to be one of those sections where you might do 30 in like 5 or 6 minutes, but then it's not, it'll take more than that. But, you know, but you might hit 1 or 2 that take a while. I want you to do 1 through 70 or 81 odd. Okay? 1 through 81 on, that's on page, it starts on page 54. What, 54? No, it starts on page 55, actually. Okay, so 1 through 81 odd, that's from 1.6, section 1.6. So now let's go on to 1.7. Good, we could probably spend the rest of Thursday, tomorrow just reviewing for this test, which will be great because it's 3 weird concepts, guys. I mean, remember, like the first day we went over an introduction to functions. Yesterday we went over to solving systems. Today we're going over simplifying exponents. It's just 3 completely different sections. So let's look at 1.7 now, which is just a continuation of exponents. Guys, this is going to look real familiar. Except the book introduces one more rule, and it's called the power rule. So it says, hey, you know what? Let's go back to that, like, why we do this. It's just a notation thing. So if I had, like, x squared raised to the 3rd power, okay? There is nothing wrong, and since it's cubed, right, we write it multiplied out 3 times. There's nothing wrong in doing that. And then the last section we learned, you just have to add these together, right? Because it's the same base. So we wind up with x to the 6th. Now you can do that if you want to. But what happened was over time, they saw this pattern and said, hey, look, if you raise an exponent to another exponent, all you have to do is multiply those together, those exponents together. Okay, the rule is, and it's called the power rule, and it looks like this: a to the m raised to the n power is just a to the m times n. Okay, that's the power rule. Now, there's a few rules that go with the power rule, and the first rule is, and I just need you to be very careful about this next one, and it's not really in this section. It's going to be in further sections moving forward. And it's when we have multiple terms being multiplied in the parentheses. So if I had, let's say, a to the m times b to the n, but now we're going to raise it to the t power. Doesn't matter, okay? What's important here is that this has to be multiplication. If it's addition or subtraction, it does not work, okay? It has to be multiplication. We'll see it can be division as well here in a second, because division is just multiplication, but it has to be multiplication. And if we have multiplication, this will distribute to all the exponents, okay? So we get a to the m times t times b to the n times t, okay? So we've got the basic product rule. We've got the product rule if we have multiplication. Well, there's also the product rule if we have fractions. And I'll use that same am divided by b to the n. Now look, there cannot be addition or subtraction in anything in this parentheses, with anything in this parentheses. It has to be either multiplied or divided. And if we raise it to a power, that's a t again, I'm going to distribute to every single exponent in the parentheses. So this becomes a to the m times t over b to the n times t. Okay? These are all the power rule. Okay? They're just kind of different versions of it. These are all the power rule, just different versions of the same rule. So let's use it. Let's use this rule. It's on page 59, guys, at the very top. I just kind of wrote it with different letters. But let's use this rule in simplifying, and you'll see it will bring in the concept from 1.6. It'll take us, those come in on the back end typically. So if we looked at, let's say, 4x squared over y raised to the second power, okay? 4x squared over y raised to, I'm kind of throwing you in a little bit of the deep end here. But first off, before we get started, we have to remember this 4 is raised to the first power, right? That 4 is raised to the first power. You're not going to multiply the 2 and the 4 together. You're multiplying the 2 and the 1 together. So I'm going to take this 2 and I'm going to distribute to all the exponents, so that y is raised to the first power 2, all the exponents in this set of parentheses. And it gets rid of the parentheses. So you wind up with 4 squared. We'll multiply that out. Let's just 16, right? X to the 4th over y squared. Okay? So I know 4 squared is just 16, so I'm going to write out the 16. So 16 x to the 4th over y squared. Okay? No repeating bases, right? 16x and y, and no negative exponents. So we're done simplifying. Kind of neat. Questions before I go on to the next example? Okay. Let's say we've got 2 over x to the negative 3, but we're going to raise this one to a negative power. We'll say negative 2. Okay? We'll say negative 2. So 2 over x to the negative 3, but I'm going to raise it to the negative 2. I'm going to start it off the same way. I'm going to think of this as 2 to the first power, right? Now, I want you to try this one. So distribute the negative 2 to both the exponents, and then simplify it completely. I'm going to hit pause here. Distribute it. Let me hit record again so I don't mess them all up on the video. So this winds up being what? 2 to the negative 2 over, hey, this denominator is going to turn positive, right? X to the 6th power, because negative 2 times negative 3. Now look, we can't have negative exponents. Do not tell me this is negative 4. That's an extremely common mistake. But we can't have negative exponents. We have to deal with the negative first before we raise the base to that number. So I've got to move this negative exponent to the denominator. Nothing's going to be left up top, so we have to have a 1 up there. This becomes 2 squared x to the 6th. So this becomes 1 over 4 x to the 6th. Okay, no negative exponents. No repeating bases. I mean, we are done. This is pretty awesome. You don't have to tell me. Okay. Okay. I'm looking at examples that they throw out there that are a little different. Yeah, okay. Try this one. Simplify this guy. This is 5 to the negative 2, x to the negative 3, y to the 11, all over x squared. This isn't a power rule question. This is just a question from the last section. That's fine. Y to the negative 5. Actually, you know what? Just to make it this section, let's raise all of these to the negative 1. I know you're thinking, oh my Lord, this is crazy. But raising something to the negative 1 is not a big deal. All you have to do is multiply every single exponent by negative 1 and then simplify. Okay, so I'm going to hit pause again, give you a little time. Okay, so I'm going to just bring in the negative 1, and really all I'm doing is multiplying every exponent by negative 1. So I wind up with 5 squared, x to the positive 3, y to the negative 11, that's an 11, over x to the negative 2, y to the positive 5, right? Okay, so let's look at these. Ooh, lots of negatives going on. Hey, 5 squared is just 25. I'll put that one down first. I'm going to move the negatives x squared up top. So this becomes x cubed times x squared, right? And I'm going to move the y to the negative 11 to the bottom. So y to the positive 11 times y to the 5th, right? All I did was make the negative exponents positive. I'm not done yet because I have repeating bases, right? X's and X's and Y's and Y's. So let's combine those together. 25x to the 5th over y to the 16th. Okay? Questions, comments, concerns? Oh, Mr. Shirley, you make this look so easy. Look, I do make this look easy. I've been doing this over a decade, okay? Teaching this, I should say, over a decade. If you've ever watched like professional sports and you watch it like golf and you go, oh my God, this looks so easy. They just swing a club and it goes right by the hole. But then you go out and try professional golf. It's a much different story. I'm not try professional golf, but try golf. It's a much different story. You've got to go try it. Math is not a spectator sport, okay? You have to get in, you have to do the homework before you understand it. I know a few people are like, no, I can just watch it. Well, sometimes if you're watching it and getting it, it's because you already had that pre-knowledge, right? You got it in high school, you just need a refresher. I'm still saying you need to go in and do the homework for it to really make sense, okay? For it to really kind of click on us. Okay. So any questions? I'm gonna hit pause real fast. Okay, I'm back. Now homework. I want you to do on 1.7. So if you want to just write this down, 1.7 numbers 1 through 55 odd. 1 through 55 odd. And I know you're like, oh my God, you gave us like 40 before and about 25 today. Yeah, but that's 2 sections, and we're gonna have a data review, and the test is until Thursday. You've got a lot of time to get this done. Okay, you have a lot of time to get these sections done. Okay, so I'm gonna stop right here and ask. First off, do you have any questions? We've covered the 3 topics really for this test. We've covered the first one was the introduction to functions, and then we covered solving systems of equations by graphing and substitution, and then today we did simplifying exponents. Okay, so are there any questions about the topics? I don't mind going over anything right now. We have a little bit of time. I mean, we've got 15 more minutes. Okay, any questions? And let me check real fast. I have to turn in like a head count thing. And I just want to make sure I've got all of you that you've been here at least once. Yeah, you've all been here at least once. We're good there. Is there any questions? Is there any question about anything else going on campus? Okay. I know I had a question. Oh, I wanted to bring up something that might happen next week. Remember, next Monday we have off for Labor Day. I might look at using YouTube Live, maybe not for this class, because I do have a few of you guys interact, especially Janie and Amanda. You guys interact with me. So it's harder to interact on YouTube Live, so I probably won't probably won't do that. I'll probably I've got another class where the students just sit behind the screen and don't say anything. Well, it's a lot easier on me to use YouTube Live because it like saves it automatically to the YouTube channel. So I probably won't do that in here. But if you have any questions though, don't be afraid to ask. If you can't get into something in the homework, okay. Oh, I do have to go over something with this class. So I was making test 2 yesterday, and I accidentally deleted test 1. I am trying to get test 1 back. If I don't, that's on me, and you guys will be the beneficiary of that. Don't freak out, okay? This is that asking for forgiveness aspect of the semester. I'm really new to making Blackboard tests, and I got frustrated and actually I deleted the wrong test. So just realize you won't be able to see it. If you go to your grade book right now, there's nothing. Like you can't see your grade. You know, where before you could see your grade. I'm trying to bring it back. If I don't bring it, if I can't get it back, trust me, it'll help you out, okay? Because I don't remember what the test grades were. So I apologize for that. That is me goofing up, and I say it won't happen again. Who knows? Okay, that's how the semester's kind of going. But if you have any questions, let me know. If you have any concerns about the class, please let me know. We're just going to keep moving forward. I'm really enjoying this mode of teaching, honestly. And I know, and I told this to Janie, because she asked me about it. I knew she was on campus. If you guys need to come to campus for better internet or whatever, or you need to come to campus because the next class is seated, you're more than welcome to go sit in the classroom that I'm teaching out of. Janie's in it right now, I believe. Are you down there in 106, Janie? Yeah, Janie's in there now. So if you want to go sit in there and kind of sprawl out on a table, there is nothing wrong with it. I'm not going to stop you from doing that. It's just hard to communicate with everyone if I've got 2 classes going on. Okay, so if you want to come to campus, that's fine. You can just go into that 106 room during this class period and get on your laptop or whatever, and you'll be good to go. If you don't have a laptop, I would stay home and do this. Okay, questions, comments? Actually, if you don't have a laptop, we might be able to check one out for you. So if that's an issue and you're like, man, my internet's horrible at the house, but I need I don't have a way to look at it, on campus, I might be able to call somebody and get you a laptop just for this class. Okay, maybe. I'm just a math faculty member. Okay, well, good. I'll see you guys tomorrow. So my plan tomorrow is just to review.